Math 230, Cuesta College. I'm Joe Vasta, and we are covering 6.4, phone numbers and more. So now we're going to actually see some of this counting applied to the real world. And we're going to kind of keep things simple with phone numbers. Let's start off with this first problem. A certain city has phone numbers starting with 543. So we're just going to assume, in these problems, assume area code 805. Okay. How many phone numbers could this city have? Okay, so let's take a look at this. Our phone number looks like this: 5, 4, 3, and then question mark, question mark, question mark, question mark. So we're assuming the area code is always the same for this area. We have 4 question marks, and underneath each of these 4 question marks I'm going to put slots. So there's 1, there's 1, there's 1, and there's 1. So we have 4 slots. So we have to decide, well, how many choices do I have for this slot? Well, it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So that was 10 choices. And what about under this slot? 10 choices, because phone numbers can repeat. 10 choices and 10 choices. So I multiply those together. We can put 3 more slots there and put 1 under there and 1 under there and 1 under there, because those are restrictions. There has to be a 5 there, there has to be a 4 there, there has to be a 3 there, but these guys could be any of the 10 digits. So this is actually going to be a 1 followed by 4 zeros. $10,000 phone numbers. So you might be living like in Morro Bay and they have like 781, 782. There's a reason for that, for people who get their phone numbers in Morro Bay with 781, 782, because that's what was assigned to that city. And this brings us to the next problem here. Dave's phone number is 78 and then question mark, question mark, question mark, question mark, question mark. And the third digit is a 1, 2, or 3. How many possible numbers could you have to call to reach Dave? So let's go ahead and put the 7 slots. I'll put 1 over here. So this one has to be 7, 8, something, and it says the third digit is a 1, 2, or 3. So we're coming back to these things called restrictions, and we could have said those were restrictions up there, so we have a restriction, restriction. With phone numbers, you can use any of these. Okay, so I have 1 choice here, and 1 choice there, 3 choices there, and then because phone numbers can repeat digits, we have 10 choices for each of those other slots. So when I multiply all this together, I have 10 times 10 times 10 times 10, which is 10,000, times 3, which is 30,000. So that's how many possible numbers you would have to call to reach Dave, 30,000. Now before we move on to the next problem, here's the puzzle for this lecture. What goes in the box? So you can try to figure out what goes in that box there. So problem number 3. Amy's phone number is 7 question mark 5 2 question mark 8 question mark. Okay, so let's set up a situation here. Say it's junior high school and this guy, he really likes Amy and he writes her phone number down. She gives him her phone number and he writes it down on his hand, and then in PE class he gets a little sweaty and some of the numbers blur, so he can't see what those question marks are. But one thing he remembers is that her phone number contains 7 different digits. How many possible numbers does this guy have to call to reach Amy? So he, maybe he'll get it on the first try, or maybe, if Murphy's Law has its way, he might have to call a lot of numbers. So here are some of the digits you would use for phone numbers. Okay, and here's her phone number right here. 7 digits. And we're assuming 805. Okay, so we'll assume the area code is known, and we'll just say it's like 805 or whatever it is. I don't know. And that's not going to play into the 7 different digits. It's these guys right here. So what is her phone number? It is 7 something 5. And then 2 something 8 something. So these guys right here are the restrictions. So how many choices do I have for this restriction? 1. It has to be a 7. And how many choices do I have for this restriction? 1. It has to be a 5, and this is a 1, and this is a 1. So let me cross those off the list. So we cross off the 8, cross off the 2, and cross off the 5. Okay, now, this says her phone number contains 7 different digits. That's why I'm crossing them off, because I'm treating this problem with no reps allowed. And that is why I'm crossing things off and writing things in green. So, how many choices do I have for this one without repeating these digits? Well, 1, 2, 3, 4, 5, 6. So, maybe we can put a 9 there. There were 6 choices, weren't there? So I'm going to cross out the 9 now and say, well, how many choices do I have for this digit of the phone number? Well, 1, 2, 3, 4, 5. So let's put, like, maybe a 0 there. And how many choices do I have for this one? Well, 1, 2, 3, 4. Whoa, maybe we can put a 6 there. So this phone number, 7952086, could be Amy's phone number. But that's one of the possible phone numbers this guy would have to call to try to get that. Well, they're asking how many possible numbers are there. So you multiply these all together, and this is all the product rule. All these problems we do, what we do with the slots and multiply things together, is the product rule. This is 6 times 5 times 4. So it's really 30 times 4, which happens to be 120. So this poor guy has to call 120, up to 120 numbers to get a hold of Amy. So see the real life applications of this. Am I stretching it? I don't know if I am or not, but we are doing counting, and some of these problems are really not as bad as the problems that we saw in 6.2 and 6.3. So let's move on to other kinds of problems here. So problem number 4. So here's 4 and 5. So 4 is talking about bit strings. Wow. Okay, so what is a bit string? We've never defined that. A bit string of length 6 would be here. Here's an example of one. So example of a bit string of length 6 would be 0, 1, 1, 0, 0, 1. What they mean by length 6, it means it has to have 6 bits in it. 1, 2, 3, 4, 5, 6. So there's an example. So they're asking in this problem, how many bit strings of length 6 are there? Well, what I'm going to do is I'm going to put 6 slots. 1, 2, 3, 4, 5, 6. Now, bit strings, you can either have a 0 or a 1. So how many choices do we have for that first slot? Just 2. Obviously, there's going to be repetitions. So the next one's going to have a 2. And the next one's going to have a 2. And it's going to be 2 all the way to the end. So this is 2 times 2 times 2 times 2 times 2 times 2. 2 to the 6th. But a way of calculating this quickly is 2 times 2 times 2. That's 8. And then here's another 8. And so 8 times 8 is 64. Now, would that be enough for lowercase letters and uppercase letters? Well, let's see. We have 26. And 26 would give you about 52. Plus, you would have to have all the numbers and a period and a question mark, etc. So that's why ASCII doesn't use 6 for the length of the bit strings, but it uses 8. So when we studied ASCII, they analyzed how many things that they would have for bytes. Remember, a byte is length 8 or 8 bits. So the counting is kind of important because it tells you how many things you have. And so there's 64 of these creatures, and this is one of them. Social Security numbers. How many possible Social Security numbers are there? Okay, well, there are restrictions with Social Security numbers, but we're not going to get into that because that would take a long time to go through all the restrictions. The Social Security numbers would look like this. So, I don't know if you know your Social Security number, but it looks like this. And they usually like to put a dash there, and then a dash there, and then have 4 there. So that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 digits in a Social Security number. So there are going to be 9 slots. Because we're not going to get into the restrictions, you can use any of the 10 digits, 0 through 9, for each of those slots. And there are repeats with Social Security numbers. Most people do have repetition in their Social Security number. And so it's going to be a 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is this? This number is 1 billion. So that's how many possible Social Security numbers there are. There's actually less than 1 billion because there are restrictions, but we're not going to get into that. But if you always wondered about Social Security numbers, Social Security numbers were devised in 1936, issued centrally from Baltimore, which is in the state of Maryland on the East Coast, and no Social Security number begins with a 000. So you know that that's already one less than this. The first 3 digits of your Social Security number, that's a geographical location. So in California, just put it over here, we have 545 to 573. But then, some of you who are born in California, you might see your Social Security number begin with a 602. And then we have 626. So in California, that's what this geographical location is. Okay, it tells you what state. these 2 digits, those are subregions. And then these 4 are serial numbers which run consecutively from 0001 to 9999. And it was like a year ago we investigated twins, and we found that the twins serial numbers, you know, one was like 5387 and then the other one was 5389, and somehow someone else must have got the 88. So very interesting thing, Social Security numbers. And even though it's less than this, this is like a ballpark region. And what happens when we get more than 1 billion Social Security numbers? You know, what are they going to do? Do they recycle them, or do they make them longer? Well, those are questions that they have to confront, but counting helps us see how many things that you can have. Let's go ahead and finish off phone numbers and more with license plate numbers. Okay. In your homework, I believe you have California license plates. So, because we were talking about the state of Maryland, we are going to talk about Maryland license plate numbers. Certain Maryland license plates have 3 letters followed by 3 digits. Calculate the number of possible license plates. So what happens is, I mean, this could happen like if someone gets hit by a car or there's an accident and you only see part of the license plate because that's all you can remember, and then they can track down things like that. They can track down who was the one who did the hit and run. So look what we have here. We have question mark, RD, question mark, 5, question mark. Okay, so this, I'm going to put 6 slots here. And we know that this is an R, D, and then a 5. So these guys right here are restrictions. And so how many choices do I have for this first slot? Well, we're just going to say, well, it's a letter and there's 26 letters in the alphabet, so we will put a 26 there. So we're not going to get into the fine details of if there's some letters that are not allowed. And then we have 1 there and 1 there, and I suppose I should have done my restrictions first. This is repetition. Repetition of letters and numbers are allowed with license plates. So how many digits do I have? Because this is letter, 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 and then we have digit, digit, digit. Well, we're going to say 10 digits, 0 through 9, so there's 10 choices here and 10 choices there. So it's really 26 times 1 times 1 times 10 times 1 times 10, or 26 followed by 2 zeros. So 2,600. So that is the deal with license plate problems. So for part B, you know, maybe you want to do this one on your own. How many license plate numbers look like this? So maybe some car hit you, and as you're lining your own blood, the only thing you see is this. You don't see the last 2 digits, and you see the Maryland license plate. And some Maryland license plates have the flag. Marylanders are very proud of their flag, and that's what the flag looks like. So you're sitting there, you just got hit by a car, you see the license plate number or part of it, and then you see this little race flag on their license plate. So let's go ahead and figure this out. Now, we could actually be a little smarter about this. I mean, everywhere there is a letter or a number, we already know there's always going to be a 1 under there. So we could just go like this. We can just say this question mark is a slot, this question mark is a slot. So what goes under those slots? Well, those are just digits. 10, 10. So how many possible license plates are like this? Well, 10 times 10 is 100. Now that's a little calculator icon. I don't know if that's visible on the YouTube video, So we're just going to say, well, how many Maryland license plates are there that have this scheme? So let's go ahead and write these 6 slots. Yes, Maryland is a lot smaller of a state than California. And in California, where this lecture is coming from, we have 7. So here it goes. Now, back in the old days, if you look at old California license plates or old license plates from other states, there are not as many slots. It's just because there weren't as many people. But as we get more people, we have to change the scheme, and we use counting to figure things out. So we have 3 letters followed by 3 digits. Now this has a calculator icon because I don't want to go 26 times 26 times 26. That's the part that I don't want to do. So I did this on the calculator and I got 17,576,000 license plates that look like that. So there it is. Phone numbers and more. We are done with that, but we do want to figure out what goes in the box. So what goes in the box? And the answer is it has to do with the arrows. See, so when one arrow hits the number, it says take the last number and add 2. So look at this. How many arrows hit this number? 1, 2, 3. So instead of just adding 2, you add 2 for each arrow. So 2, 4, 6. So 10 plus 6 is 16. So we have 1 arrow going into that. So we just add 2. 1 arrow, we add 2. We have 2 arrows going into that. So instead of adding just 2, we add 4. And then we have 1, 2, 3. So that's 2, 4, 6. We add 6 to that. This gives us 30. 30 is the answer to the puzzle. So this completes section 6.4. Our next section, we are going to be talking about factorial notation. We're going to go to a weird kind of ice cream shop called the No Rep Ice Cream Shop and learn about something called permutations and combinations. So it's going to hopefully stay interesting. This is the math you don't do in a regular algebra class. Hopefully it's funner math. Do your homework. Have a good day. I'll see you in the next video.